Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today I am going to discuss on the topic that is eutrophication and then restoration of lakes. So first we will start this term, that is eutrophication. Eutrophication means it is a process by which a water body slowly becomes rich in plant nutrients like nitrate nutrients and phosphate due to sometimes soil erosion or runoff from the surrounding land. So it is we can say that eutrophication is that kind of condition which is created in a lake or a pond due to the addition of excess of nutrients, and these nutrients are mainly two nutrients, that is nitrogen and phosphorus, and it is all due to the addition of water from soil erosion or sometimes runoff from the surrounding lakes also. And next point is that eutrophication of water bodies results into the large amount of nutrients by the action of aerobic bacteria on organic waste that is going to be entering human body naturally or by human activities also. So this is about the eutrophication. Like eutrophication is nothing but it is the enrichment of nutrients inside a lake. So enrichment of nutrients into a lake is called as eutrophication. Means what will happen due to the surface runoff or from soil erosion, two nutrients is there, that is nitrogen and phosphorus. So what these two nutrients will enter into a lake or a water body, and this will be due to entering of these nutrients, automatically the amounts of bacteria and organic waste into is going to be increased, and due to this increase of these nutrients, algae and all fishes all are going to be very increased in too much amount. So this kind of condition is called as eutrophication, and it is all due to and then what will happen after this eutrophication, that water body is changed into a large amount of nutrients by the action of aerobic bacteria on organic waste. Means what will happen by the action of some organic bacteria, organic waste, and then this waste is sometimes enters into the human body, sometimes by naturally or by sometimes human activity, some anthropogenic activity is there. So this was about eutrophication. Eutrophication, we can say it is a types of water pollution also, because with the increasing of this limiting nutrients, that is nitrogen and phosphorus, automatically the water will become dense. Due to the dense, fishes can't breathe, and some phytoplankton, zooplankton is going to be die, and sunlight will not reach up to the bottom of the lake, and in this way dissolved oxygen is reduced. This will be cause too much harm to the lake system, and that lake will changed into a eutrophic lake, and some stagnant smell will come out, and sediments will be filled inside the lake because sunlight will not reach up to the bottom of the lake. So in this way, no sunlight availability and fresh water or dissolved oxygen is there in this lake. Now comes to the next point, is the causes of this eutrophication. So it is sometimes it occurs by natural processes also. Eutrophication is caused by two types. First one is a natural eutrophication, and second is a man-made. Means those eutrophication which will be created by the human activities. So natural causes is that it occurs because of the natural process of aging of lake, during which nutrition status of water system gradually increases, and oligotrophic lake is converted into eutrophic lake. Oligotrophic means shallow lake. Oligotrophic means shallow lake, means those lake, they have a shallow water and the sunlight can enters into that up to the bottom of the lake. So what will happen, sometimes due to it will be caused, this eutrophication will caused by natural process also. It is that we can term it as a natural aging of the lake. What will happen, neutral status of water system gradually increases. The nutrients present in the water system is gradually increasing, and this oligotrophic means shallow water lake is going to convert into a eutrophic lake. Eutrophic lake means dense lake, and due to death of aquatic plants and animals, it also increases nitrate and phosphate content of water. So because what will happen, organisms is also die due to aging of the lake, and this will be going to add nitrate and phosphorus content of the water. So this was we can say that they are the natural reasons of eutrophication. It is generally we can term it as a natural aging of the lake. Next point is that sometimes it will permit the production of phytoplankton, algal bloom, and aquatic vegetation. That is, vegetations are water hyacinth, aquatic weeds, water fern, and water lettuce, and that will provide too much food for herbivores or zooplankton and fishes. So this are all are the reason of the natural eutrophication. But because sometimes this phytoplankton will permits the production of algal bloom and aquatic vegetation, all because of this water hyacinth, aquatic weeds, water ferns, and water lettuce. This will be then going to provide ample food for the herbivores, zooplanktons, and fishes. So this was about the natural causes of eutrophication. Eutrophication natural causes is nothing but it is a aging of a lake. Aging of a lake is called as eutrophication of lake. Now comes to the next thing, that is man-made cause of eutrophication. Why this will happen? The reason behind this eutrophication, man-made reason. So process is generally speeded up by human activities. Due to human activities, this eutrophication has increased. So it is called as man-made cause of eutrophication. So what will happen? This will be responsible for the addition of 80% nitrogen and 75% of phosphorus to the lakes and streams. Use of NPK fertilizer, mostly fertilizer that is used in the agriculture system is mainly the NPK, nitrogen, phosphorus, and potassium. So due to agriculture runoff, this nutrient and phosphorus will going to be enters into the water bodies. And discharge of domestic and industrial waste, these type of waste will also contains nitrogen and phosphorus. Some detergents is there, urban discharge, animal waste, and sediments into water bodies, that will leads to the cultural eutrophication. So these kind of things, these kind of pollutants are there. They are like NPK fertilizer is there, discharge of domestic and industrial waste, these are the water pollutant, detergents, urban drainage, animal waste, and sediments that will be going to enter into a water body, and this will lead to the cultural eutrophication. You can understand this in the picture. This here what will happen due to this entering of these kind of chemicals like NPK fertilizer, then animal waste, industrial waste. With the addition of these nutrients inside the lake, automatically it will be going to be doubled, and this will leads to this type of condition that is called as eutrophic lake. And eutrophic lake, this eutrophication will cause in any lake. So it can be a natural also, sometimes it can be a man-made also. So in both of the way, this eutrophication will cause some. Its reason is natural sometimes artificial, human made also, because the use of lots of fertilizer in agriculture will leads to entering of the soil runoff into the water sediment, that is NPK fertilizer, and then discharge of domestic and industrial waste into the water system, detergents, urban drainage, animal waste, and sediments into the water bodies, that will lead towards this cultural eutrophication. So now we are going to understand about the mechanism of this eutrophication. What the mechanism is involved behind this the process of eutrophication. So it will be mainly arise from the oversupply of nutrients that leads to overgrowth of plant and algae. So the oversupply of these two nutrients, nitrogen and phosphorus. What will happen after any organism will die? The bacterial degradation of their biomass consume the oxygen in water, thereby creating the state of hypoxemia. Hypoxemia means less oxygen is there. So this kind of condition will be created into a pond because of many organisms will die, and the bacterial degradation of these of their biomass consume the oxygen in the water. Means those all are consuming the already present oxygen into the water. So there is a scarcity of oxygen. So this kind of state is called as hypoxia. Means oxygen is going to be very less amount. So that kind of condition is called as hypoxia. So during this oxygen, if oxygen will not present, automatically many organisms will die. Sedimentation will occur, and due to no sunlight will come in up to the bottom of the lake. And the primary limiting factor of eutrophication is phosphate. Phosphate is a necessary nutrient for plant to live, and it is a limiting factor for plant growth in many freshwater ecosystems. So this phosphate is also a reason behind this eutrophication. But one more thing is that it is a limiting nutrient for the plant, for this plant, because plant is a very essential nutrient for plants to live, and is a limiting factor for plant growth into a freshwater ecosystem. So the availability of phosphorus generally promote excessive plant growth and decay. And on the other side, nitrogen is also there, and this nitrogen in the form of nitrates sometimes play a vital role in the eutrophication process. So these two nutrients, phosphorus and nitrate, will be responsible for this eutrophication condition, and plant growth is increased, so that decay will also increase. And on the other hand, in the form of nitrates, nitrogen play as a vital role in the eutrophication process. And then what will happen? Phosphate and nitrate adhere tightly to the soil, so it is mainly transported by leaching and erosion. So soil erosion is again an important factor of this eutrophication. Surface runoff is also a reason of this eutrophication. So once translocated to lake, the extraction of phosphate become very tough. So it is difficult of reversing the effects of eutrophication. The main source of these phosphate are the phosphates in detergents, because in detergents that we are using, phosphate is already present. Industrial and domestic runoff is there, fertilizer is there. So whatever the pollutant is coming inside the water is already rich in these two type of nutrients. We are using detergents, industrial effluent is there, household effluent is there, agriculture effluent is there, all will contain nitrogen and phosphorus. So because of this, too much sewage, too much runoff is coming inside the water bodies, and this will lead to the condition of eutrophication, because more amount of phosphate and nutrients is present, and already these are the limiting factors. So that it is important for the survival of plants also, but it is present in too much amount. So due to too much amount, excessive growth of plants and animals inside a water body will happen, and its decay is not possible in that short span of time. So in this way, any good lake, any shallow water lake will converted into a eutrophic lake, and this type of condition will create inside a eutrophic lake. And next is the sodium triphosphate is there. It is a component of many detergents, and it is a major contributors of eutrophication. You can see the picture of sodium triphosphate, and this sodium triphosphate, 3-phosphate is there. It is the components of mostly detergents, and it is the major contributor to the eutrophication process. So this was the mechanism behind this eutrophication. So in this picture, you can understand these things like what will happen. Neutral load is there, that is excessive nutrients from fertilizer are flushed from the land into the river or lakes or by rainwater. So these nutrients and pK, nitrogen and phosphate, and sunlight is there. So what will happen in the second step? This will going to nourish the plants. These pollutant causing aquatic plant growth and algae, duckweeds and other plants is there. And then due to the sunlight, algal bloom will happen. Oxygen is depleted. Means more amount of algae growth is already increased. So this kind of condition is called as algal bloom. Means rapid increase of the population of algae is called as algal bloom, and this will be going to deplete the oxygen level inside the lake or water system. So what will happen? Algal bloom this algal bloom is going to prevent the sunlight to coming inside the water body. Since no oxygen will be present inside the lake, this will lead to the condition of hypoxemia. So reaching the water, and the plant die, and oxygen in the water is depleted. So already if the sunlight will not enters into the water system, it will not going inside the water system, because more and more algae is there on the top of the water system. So in this way, death of ecosystem is there, means many organism death is there, and oxygen level reaches to a point where no life is possible, means oxygen amount is going to be depleted. Oxygen is depleted. Oxygen is depleted, and due to addition of these two type of nutrients, and algae growth, rapid increase in algal growth is there. That condition is called as algal blooms is there. Algal blooms, and then oxygen is going to be depleted, and this will causes the plant and oxygen to die. And next is the oxygen level is going to be reduced at a very low point, and this will be where no life is possible into a water body. Fish and organism is going to die. And then what will happen during the process of decomposition? Dead plants are broken down by bacteria decomposer, using up even more oxygen in the water. So in this way, decomposers will do their work, but if no oxygen is there, if no nutrients is there, then this will be going to be very tough condition for the decomposers, because already whatever oxygen is there inside the lake, these decomposers will use it for the production, for the decomposition of organic matters from the dead organisms. So this condition, we can say that it is a condition of eutrophication. With the increasing the time, automatically nutrient load will come, and this will be going to inside a plant. At the starting stage, this nutrient will nourish the plants, but after some time, algal bloom is there, algal rapid increase in algae growth is there, and this algal bloom will restrict the sunlight to enter into the water body, and this will be going to reduce the depletion of the sunlight into the water bodies. No oxygen is there, and then this will leads to the decomposition of organic matter, and during this decomposition of organic matter, it will need more oxygen, so it will not be able to provide more oxygen. So oxygen level leads to a point, it will reduce up to a point where no life is possible inside that pond. In this way, a normal shallow pond is going to be converted into a eutrophic pond. Eutrophication. So this was the process of eutrophication. You can see that with the time, means this eutrophication is sometimes caused by natural process also. So it is natural also, means it is a natural term. We can see that it is a aging of a lake, but nowadays water pollutants are more, so that it is a very common for any lake, and time to time this cleaning and restoration of lakes is very much important. Now comes to the sources of eutrophication. Means we will divide the sources of eutrophication in two sources. First one is the point source. Second one is the non-point source. Point source means nutrient waste travel directly from a source to a water. Means their discharge is fixed at a one point source is there. One point source is there. So it is very easy to regulate. Like example is the wastewater effluent, some municipal or industrial effluent, runoff and leachate from waste disposal system, runoff and infiltration from animal feedlots, and runoff from mines, oil field, unsewered industrial site. Means this will be a runoff from any sources, like this can be called as point sources. Runoff from any sources, like from wastewater effluent, runoff from any leachate source, infiltration from animal feedlots, runoff from mines, oil field, like that. And next is the non-point source. Non-point source is that in which come from any diffuse sources. So non-point sources are difficult to regulate and usually very spatial and temporal. So this non-point source can be anywhere. It is a leakage of water from anywhere. So this non-point source is very tough to find a place. So, and its example is a runoff from a pasture and rain, septic tank leachants, runoff from any construction sites. That is so the runoff that is coming from any pasture or land, from any septic tank leakage, sometimes runoff from any construction site, is a non-point source. Means their generation point is not fixed. Then it is called as non-point source, and point source, their generation point is already fixed. So from there, these nutrients are coming, these pollutants are coming into the water bodies, and this will leads to the condition of eutrophication. So the generation or source of eutrophication is of two types. First one is a point, means a fixed point is there, like industrial effluents, runoff from animal feedlots, and wastewater effluent is there. And non-point source means their point is not fixed, it is coming from anywhere. So it will be, we can say, leaches from any septic tank, and runoff from any pasture or pasture rains. So this was about the sources of eutrophication. You can see this in the picture, like nitrogen compound is coming from by some cars and factories, car factories. Discharge of some detergent, that is phosphorus, that is coming from municipal solid waste. And next is the discharge of treated municipality sewage, that is primary and secondary treatment is there, so that is also rich in nitrogen and phosphate. Next is the lake ecosystem nutrient overload and breakdown of chemical cycling. So this, due to overload or breakdown of chemical cycling, it is also coming. It is a natural runoff, nitrate and phosphorus is there. Inorganic fertilizer runoff, again nitrate and phosphorus is there. Next is the manure runoff, so feedlots, then again nitrogen, nitrate, phosphate and ammonia is there. Runoff from any street, lawns and construction lots, so this is also there, nitrate and phosphorus. Runoff and erosion from any cultivation, mining and construction and poor land use. So these are the different sources of eutrophication. Like this water is coming from everywhere, whatever the source is, either it is point source or non-point source, both it will contain this nitrate and phosphorus. It is very much rich, means any sewage is there, anything entering into the water as a pollutant, these two nutrients are already there. So that's why it is a new limiting nutrient also, but it will be, if it will be present in more and more amount, automatically this will be a very much dangerous for the water bodies. Next is the effects. We are going to discuss about the effects of this eutrophication. So eutrophication will lead to a various physical, chemical and biological changes in the water, deteriorating the quality. It will lead to the water pollution. Mainly, first thing is that this eutrophication will lead to the water pollution. Algal bloom is there. That is the rapid increase in the algae is there. Next is the enriched nitrogen and phosphorus contained in water bodies, that is facilitate heavy growth of aquatic plants like algae, that is causing algal bloom, which prevents penetration of lights into deeper layer. So due to more amount of nitrogen and phosphorus, algal bloom is there. So this algal bloom is causing the prevention of these sunlights to comes into deeper layer of the water body. Next is the decomposition of algal blooms deplete the oxygen level and increase carbon monoxide level in the water, and this condition is called as hypoxia condition, or increase in carbon monoxide. So due to poor supply of oxygen, aquatic organism begins to die, which turns the clean water into a stinking drain. Obviously, this clean water will change into a stinking drain, means smell will come out, and this is called a stagnant pool also. So this was a effects of eutrophication. This will be cause death of many aquatic organisms. It will be leads to the water pollution. It is causing algal bloom. So this was a general effects of eutrophication. Now comes to the next part of the discussion. Example for this eutrophication lake. So first example is the Uday Sagar Lake, that is situated in Udaipur, Rajasthan. This in this Rajasthan state, this Uday Sagar Lake is there. So this lake will change into a eutrophic lake. Eutrophic lake due to the addition of nitrate and phosphate, and the high phosphate content due to discharge of pollutants. Water from where this pollutant has come into this lake is from surrounding phosphorite mines is there, some chemical factories is there, distillery and domestic effluent is there. Due to this addition of nitrate and phosphorus into the lake, you can see that algal bloom is there and green shade of algal bloom is there, that will be witnessing the eutrophication condition of this lake. So this, because the white water is changed into a green water, means more algae is there. This condition is called as algal bloom condition. So it is in this Uday Sagar lake is becomes a eutrophic lake due to addition of discharge of pollutant from surrounding phosphorite mines, chemical factories, distilleries, domestic effluents. Now comes to the next example of this eutrophic lake. First is the Dal Lake in the Srinagar. It is a very famous lake in Srinagar. It is named as the jewel in the crown of Kashmir. The lake is an important source of commercial operation in fishing and water plant harvesting. So this lake covers an area of 18 square kilometer and is a part of a natural wetland which covers 21.1 square kilometer. So due to increasing urbanization, industrial discharge and use of chemical fertilizer around the area, it has resulted in the pollution of lake causing eutrophication. So this eutrophication condition has caused in the Dal Lake of Srinagar also, and this lake is a very important lake of this Srinagar because for commercial purpose, fishing and water harvesting plant is there. So once this lake has been turned into a eutrophic lake, then many they have things they have applied for the restoration of lake. So now we are going to discuss about the restoration of the lake. Restoration of the lake means what will happen. It is a general term used for an standing water. As we already know, lake is a very common term that we can use for a standing water. So generally large enough of the area and depth is there, but irrespective of its hydrology, ecology and some characteristics. So these water body was primarily the drinking water sources of water supply, irrigation and recreation also. So marginal aquatic vegetation is to be promoted because it checks erosion and helps improve water quality. So most lake pollution problem is caused by nutrients contamination, so NPK, and sediments carried into the lakes. So soil particles carry more than 90% of the organic nitrogen and phosphorus originating from upland agriculture practices. So restoration of the lake, what will happen? Any lake will have very high pollution is there, water pollution is there, and most of the reason behind this restoration, behind this eutrophication is that what will happen, some sediments carried into the lake and soil particles carry more than 90% of the organic nitrogen and phosphorus that is growing to increase in the upland agriculture practices also. So what will happen, lake restoration method is the restoration of lake for the improvement in water quality that will require therefore intervention that address both factors responsible for an increase in nutrients load and accumulated nutrients also. So it is a method to bring back that nutrients into the lake also. So it is an improvement in water quality, improvement in the water quality of lake, and reduction in water pollution, water pollution. So this will lead towards the restoration of lake. Restoration of lake has been done to reduce the water pollution and to bring back the original water quality of any lake, and it will be both the factor responsible for an increase in nutrients and accumulated nutrients. So different method that has been adopted for the restoration of lake is the preventive or indirect methods or ameliorative or direct methods. So indirect method involve the approach is useful primary for controlling non-point sources of pollution, means this will be especially for the non-point sources of pollution which are incidentally to the land use or drainage basin of the lake. When non-point source of pollution can be incidentally land use of a drainage basin of the lake, it can comes from anywhere. So this indirect method has been mainly involved for the non-point sources. So in this alternative drainage basin alteration that will be improved, it will be involve the use of structural and land treatment measures, because this will be coming from any structure area or some land treatment area. So the interception of nutrients and sediments before they reach the lake, before treatment is there, so this will be not be able to enters into the lake, and this the main soil erosion management practices including what will happen, terracing is done, contour farming is there, grassed waterways, conservation of cropping system, Next is the crop residue management, or increase in the amount of residue after harvesting. So this was the general method for the stop of this restoration of lake. These are the drainage basin alteration. Next is the diversion of waste, means sewage effluent were the main source of lake eutrophication. So it should be diverted to the different place, so that it will be not be able to enter into the water bodies, and their diversion results into the marked improvement in the quality as measured by increase in transparency, decrease in phytoplankton biomass, and increasing species diversity also. So this was about the diversion of waste. Sometimes sewage effluents is there where the main source of lake eutrophication. Their diversion related results into the marked improvement in quality of water as measured by increase in transparency, decrease in phytoplankton biomass, and increase in species diversity. Next direct method that has been used for the restoration of lake is the mechanical harvesting of biomass. Means some mechanical devices is used to collect this harvesting of biomass, means to collect the this green algae. Next is a lake deepening of drenching of lake, admission of unpolluted water like dilution or flushing is there. Then water aeration. Water aeration is done to increase the dissolved oxygen condition. Increase the dissolved oxygen condition. Increase DO of water. So this DO is the dissolved oxygen. Then hypolemnitic drain is there. Lake draw drawn is there. Lake bottom sealing is there. So these are the some physical methods we have adopted for the direct restoration of lake. Next, in lake chemical method is also adopted to add with the addition of some chemicals. This restoration can be achieved. So first is the phosphorus precipitation method. Some precipitate will be added that will make precipitate with the phosphorus. Use of algicides and herbicides. Algicides has been used to kill the algae and herbs that is already present in the water. And next is the in biological lake method is the sometimes species manipulation is the main in lake biological methods for lake restoration. So this method is considered as the introduction or promotion of organisms that are inimical to the target organism. So with the addition of any new species that will be enemy to the target organism. So temperature, what in nature, predator by zooplankton and fish species keep a sort of control on algal population. So the predators for the zooplanktons and fish species are like a control on algal population. Next, biological in-lake control measures are still in their infancy and are not widely now used because this will be not much successful. So this was about the restoration of lake. Now comes to the next point, that is sometimes what will happen, they will do outside lake chemical method is there. So some method involved in this is the clarification method, active carbon adsorption method, ammonia stripping, nutrients and iron removal, disinfection. So these are the outside lake chemical restoration methods. Outside lake biological method are the primary treatment of sewage is achieved with plain sedimentation. Plain sedimentation is there, so these nutrients will not be able to reach inside the water system, and the fresh solid contain most of the settleable solids in the raw wastewater. And an aerobic digestion destroy about 67% of our volatile matter, and about a quarter of it is covered to fixed solids. So this can be achieved by some settleable solids in the raw wastewater. And the secondary treatment will include things like trickling filter and activated sludge process. Advanced wastewater treatment methods and processes remove more contaminants from wastewater that are usually taken out by conventional secondary treatment plant. So these are the restoration of lake plants by outside methods, by some chemical methods. So first of all, it will involve the biological method. So primary treatment of sewage is with a plain sedimentation. Next, secondary treatment is there where settleable solids in the raw wastewater during the aerobic digestion destroy about 67% of the volatile matter, and quarter of it is converted into fixed solids also. And the secondary treatment includes, then secondary treatment process is going on, as we have already discussed about the trickling filter and activated sludge methods. These are the advanced treatment methods and the processes that is going to remove contaminants from the wastewater and are usually taken out as a conventional secondary treatment plant. So this was about the restoration of lake, and the pollution of lake will leads to eutrophication condition, and how any lake can be restored into a normal condition is called as restoration of lake. So we have already discussed about the eutrophication. Eutrophication is all caused due to two nutrients, nitrate and phosphate, and due to increase in their amount, all the algae that is present in the water is going to be increased with the sudden increase of the nutrients, and their rapid growth is there. Due to their rapid growth, sunlight will not be able to enter into the water bodies. In this way, any good water depletion condition will occur. During this water depletion condition, oxygen deplete condition is there. This condition leads to any ponds into a eutrophic lake or a eutrophic pond. So this was about the eutrophic pond, and we have already studied about the restoration of lake, means how to preserve that lake again back to their normal processes. And this eutrophication is caused by sometimes natural causes, is also like that. This leads to the aging of the lake, and sometimes man-made reason is also this behind this eutrophication. And this was all about eutrophication and eutrophication and the restoration of lake. Thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.